Of introducing my friend Sam Culpepper. Sam is from Southface. I think Matt did a great job of kind of explaining a little bit about what Southface does and what they do. Great sustainability company in Atlanta that helps out all over the state with all kinds of great things going on. Sam has done a lot of work on our building, specifically on the carbon impact of the building and what that means, and is going to talk about the carbon impacts of mass timber, as well as the Georgia Carbon Registry. Sam?
Good morning, everyone. So thanks, Troy, for the introduction. I'm Sam Culpepper. I lead the design consulting program at Southface. If you're not familiar with Southface, we're a 47-year-old nonprofit just across the street. We do work in the built environment, focused on sustainability. We do everything from energy work, water work, and more recently doing a lot of work around embodied carbon and the sustainable benefits of timber construction. So what we're going to be talking about today is a new vehicle, a value add for timber construction in Georgia. This is a Georgia-specific thing. So it's called the Georgia Carbon Sequestration Registry. So we're just going to dive right in on this. So Georgia has had a carbon registry for a long time. It's been focused on timber products. So originally established in the early 2000s, focused on timber land. It was a way to basically have some analysis done on a stand of timberland and track the carbon sequestered amongst those trees as they grow. So every 10 years or so, you could sell carbon credits for the carbon you have sequestered within those trees. In the early 2020s, there was a bill passed to actually expand the carbon registry to include timber in buildings, so sustainable building materials. And this was a first in the nation measure, and it looked at carbon sequestered in two different ways. One, the actual carbon sequestered within timber, so about 50% of mass timber by dry weight is carbon, and then also avoided embodied carbon. So that's basically if you're using mass timber in lieu of concrete, you can compare the embodied carbon impacts of both, and you can take credit for the reduction in embodied carbon by utilizing timber. So this is now an active protocol. It took a few years to actually develop the standard, but it's now in place. And the Carbon Sequestration Registry is administered by the Georgia Forestry Commission. And it has a few quirks in its application, so we'll kind of talk through how that works. Typically, a project that is pursuing registration to get these carbon credits, it requires the architect and the engineers to basically complete a life cycle analysis. So that can be done by that design team, or they can bring on an LCA specialist. And another component is a requirement for a third-party verifier. So we'll talk about it in a little bit. There's a few people who are qualified to do that. And that whole group kind of operates in one entity. So they'll put together the whole submission package to the carbon registry. That's submitted to the Georgia Forestry Commission staff. And then once they review and approve all that, you're actually entered and registered on the Georgia Carbon Sequestration Registry. So each metric ton of embodied carbon that you are sequestering or avoiding is entered on the registry. They're all tracked individually, and it's split between the two tranches, the sequestered carbon and the avoided embodied carbon. So all that's maintained by the Georgia Carbon Sequestration Registry, which is a standalone entity that basically exists just to do that. So across a building, you can track and register for basically any component that is built more sustainably. The primary focus items tend to be structural and envelope measures. So we're talking about foundations, the vertical and horizontal structure, and any cladding, the major impacts for embodied carbon. So exterior framing and cladding, insulation materials around the building, the glazing systems, and roofing materials. All those things can be quantified and used for the registry. So when talking about carbon credits, often there's a need for additionality. You need to say, we are either adding, we're doing this basically to add some sort of reduction, and you wouldn't just normally do this. So one of the benefits of the carbon registry is in the legislation, they said by choosing these materials, we're just going to assume that you're meeting the standard for additionality. So you don't have to prove anything on that. All the projects within the registry are measured against a 100-year project lifespan. So if your building, for whatever reason, is not anticipated to have that, they prorate the amount of credits that you get. So if you only have an 80-year registry, you're only going to get 80% of the credits you otherwise would normally have. And also, the Georgia Forestry Commission retains a certain amount of the credits, 5%, in a buffer pool, which is basically if there is a project that does not meet that 100-year lifespan, and so the credits are not fully worth their full value, they can use some of those buffer pool credits to make up for that difference. So the third-party verification, there are 3 third-party verifiers that are approved. Matt Kentner is one, I am one, and Kelly Roberts with Walter B. Moore is another. We're all based in Atlanta. If you're interested, feel free to reach out. We'd be happy to talk through the process. And basically what the third-party verification, the main tasks that we look at are, we act as a true third-party verification. So the project team typically has completed an LCA or a series of LCAs for the project. We take all that data, review it against the as-built documents for the building, and make sure that everything actually makes sense. So we're reviewing for reasonableness. We want to make sure that, if there's a 0.1% difference between something, we're not going to worry about that, but if there's a 10% difference, we're going to track that down. So we'll talk a little bit more about the specific things here in terms of a life cycle review, but it's basically, we act as a technical adjunct to the Georgia Forestry Commission to help review these items. Okay, how many people here are at all familiar with whole building life cycle assessments? A little half hands, okay. Great, so this is a lot of information that we're going to just bounce right over the top of. So basically, when you look at a whole building life cycle assessment, it's kind of broken out into modules. So the A module is the first 5 items here. At the first box, this is GCSR scope, is the A module. So that's basically from raw material creation, like we're extracting raw materials and turning them into products, and then delivering them to the site and actually building a building. So from A1 to A5 is effectively the construction process, from material acquisition to building handover. The B module is operations. So that's if you look down at the bottom, there's B6 and B7, the operational energy and water, but there's also all the maintenance and repair work that goes on during the building. You can quantify all this, and a whole building life cycle basically looks at A1 all the way through C4 and the other modules on the right. The C modules are basically, it's the end of life for the building. If you deconstruct the building, where does it end up? What's recycled? What goes to landfill? What energy is used to move all the materials around? And so within the Georgia Carbon Sequestration Registry, you're required to report on A1 through A3, which is basically that raw material manufacture. That's typically what's reported in a environmental product declaration. And then also A4, which is basically moving those materials from the factory gate to the project site. You can also report on A5, which is the energy used during construction. That can be the energy used by the cranes, or the energy used to deliver the concrete, those kind of things, but it's not required within the registry. So a whole building life cycle assessment will basically take quantities of all the different building materials, apply the carbon impacts based on those quantities through the EPDs, and then you get a carbon footprint. So the process for looking at this, typically, you start with a schematic building design. If you are pursuing the registry, it's helpful to have a timber design and a concrete design to be able to compare the two impacts. So that's often the case in schematic. You're looking at those two cases, and then as the design develops, the timber, if the pricing works out, everything's moving ahead, then the timber design typically gets a little bit more developed, but you still have a basis that you can compare the two between concrete or steel and timber. And then as you move through the construction documents and move into construction, the information that is needed for the Georgia Carbon Sequestration Registry is those final quantities, the actual as-built data, and any tracking on distances, things like that. All that needs to be retained. And then after the building is completed, typically that's all handed over to the third-party verifier to build out the final submission. It's submitted and then submitted to, reviewed and then submitted to the Georgia Forestry Commission. And once they approve it, you're issued all of your credits. So the first project to be registered is actually 619 Ponce. I was the third-party verifier for that project. So we've been talking about a lot, so I'll just kind of run through these pretty quickly. I'll talk a little bit more about the distances involved. So Troy talked about how the timber was harvested in Georgia, went to Smartlam in Alabama. The CLT went straight from Smartlam to the site, and some of the glue lambs actually went up to Souder in Tennessee and then back down. So there's a little bit more distance involved in those, and that was accounted for in the life cycle assessment. So this project took advantage of both the carbon sequestration path and the avoided embodied carbon path. So the comparative case here was the as-built mass timber design versus a concrete slab and beam system. So the foundations were actually excluded from this comparison. There's structured parking below grade, and it was deemed basically that they would have designed the lower levels the same either way. So that's excluded. So what we were looking at was basically the above grade structural systems, and also the envelope was excluded. That was essentially considered the same. It was cold form steel framing for the exterior walls. So we just left that out of the comparison. So the concrete base case, the total embodied carbon for those elements, basically the horizontal and vertical structure, was about 1,400 metric tons of CO2e. Compared to the mass timber case, it came in around 550 metric tons of CO2e. So there's a big avoided embodied carbon delta there, about 870. And then when we looked at the sequestered carbon, the embedded carbon within the timber, that was almost 1,600 metric tons as well. So for the carbon registry, you actually can take all of that together for a total reduction of almost 2,500 metric tons. So that there's some of the 5% of that gets slotted over to the buffer pool, and then a total amount of 2,362 metric tons of CO2 were registered with the project. So that's about the amount of equivalent emissions of 317 average American homes' energy usage. So that's one project reducing that much embodied carbon in basically a 18-month period. So there's a lot of value in looking at these embodied carbon reductions. We do a lot of work around energy efficiency, reducing a building's operations by enough to realize a 2,400 metric ton of CO2e result requires a lot of work. And this is a great way to help reduce the total impact of buildings up front in big swings. So once the carbon credits have been issued by the Georgia Forestry Commission, there's a real question as to what exactly you do with them. So we are in a voluntary market for carbon credits. We don't have any sort of compliance structure. You're not required to buy carbon credits to offset your usage like in California or other markets. So what we've seen is that carbon credits in this market range from $7 to $15 a metric ton. And in compliance markets can be north of $75 per ton. But basically these credits go to the building owner and they can be held and hoping that they accrue more value, or they can be sold or traded in any sort of transaction. If you were pursuing a program like ILFI zero carbon program, where you're looking to fully offset the building's embodied carbon, you would immediately retire these credits as a way of saying, basically, we have formally and permanently offset the building's embodied carbon by this amount. Or you can sell the credits to someone else and have them retire it to reduce their carbon emissions. And so there's a number of different ways that you can treat these credits. Yeah. So that basically wraps up the discussion of this. Are there any questions about the sequestration registry that I can address right now? Otherwise, we'll hand it off to the next speaker. Yes.
Thank you. I was just curious, how many total projects are in the registry now?
One. Yeah. So it's not necessarily a storming event going in there, but there are a couple of other projects that are have already been completed and are looking to get registered. And it's definitely something, any new mass timber project, you do have to have the life cycle analysis completed to do this. So any project that has that analysis completed is eligible to register, even if it was 10 years ago. So, yeah. Thank you all.